Hi everyone, this is Lavanya from Department of CEC. Today topic is multiple process scheduling under operating system. In this, we have already seen what is a single processor system and what is multiprocessor system. When multiple CPUs are available, load sharing is possible in that system, but scheduling problems occur because since multiple CPUs are involved in a single system, and it is little bit complex to design which CPU is responsible for what are the works and resource allocation and job allocation, etc. In this, basically multiple process scheduling is categorized into two types. One is symmetric multiprocessing, that is SMP, and another one is asymmetric multiprocessing. Let us see what are these two types. Okay, first we are seeing asymmetric multiprocessing, a processor which has uh, to schedule the IO processing decision and what are the system activities to be handled by a processor. In this, all these tasks are done by a master server. Okay, in asymmetric multiprocessing, master slave or boss worker relationship is carried out. In this, the master is responsible for all of this and it allocates job for the slaves. It doesn't do any execution. Other than that, it use only the monitoring job and allocates the work for the worker or slave processes. This asymmetric multiprocessing is simplest one, and the process assist is reduced because only one master is responsible for all the monitoring job and data sharing and work allocation. So in this, the sharing of work is simple and it is of less complexity whether compared to symmetric multiprocessing system. In symmetric multiprocessing system, in this each processor is self scheduled, that is there is no master slave relationship or boss worker relationship. Each CPU will work on its individual task concurrently and parallelly without depending on the other process. All process may be in present in the common ready queue, whereas each process might have its private own queue for the process which are ready for that execution. Regardless of scheduling process, the scheduler needs to examine the ready queue and select which process to be executed. This is done by the individual process. There is no one to allocate job for a particular process. This is symmetric multiprocessing. If we have multiple processes trying to access a common data structure, in this the scheduler must be performed carefully because it can't allocate the same resource for the more than one processor. Okay, we must ensure two separate processors do not choose the scheduler of the same process, because if a single work is getting shared by two processes, then there will be of data concurrency and irrelevancy. So for the better performance of the system, we must schedule that a particular task is completely allocated for a particular process. If the process work allocated is not of bulk quantity, if it is of large task, it can be splitted and run in parallel in more than one processor simultaneously, and finally the result can be combined together. At the time, the scheduling must be proper, and the information and resource sharing and the updation of any resources and the data must be constantly updated to the all the caches of the other processors also. This is the only process we are facing in multiprocessing symmetric multiprocessing system. Okay, the process should not lost the queue and the content must be safe while sharing and executing in symmetric multiprocessing system. This is the two types of execution of symmetric and asymmetric multiprocessing system. In simple way, if we want to say, symmetric multiprocessing is nothing but if, for example, 10 processes are connected parallelly, each 10 process will be performing 10 tasks simultaneously without depending on any other, and there is no one processor to control it. In asymmetric, if I want to say 10 processes are connected, one process will be acting as a master, and it will control and allocate work for other sub 9 processes. 9 will be performing and one will be monitoring. This is asymmetric multiprocessing. I think you got a clear idea about symmetric and asymmetric multiprocessing in this session.